we're tackling, well, one of the biggest questions in physics, really.
It's a huge one.
Yeah. How do you connect Einstein's theory of general relativity? Gravity, massive structures, the cosmos with quantum mechanics, the really weird physics of the tiny.
Two incredibly successful theories.
Monumentally successful.
Yeah.
But fundamentally, they just don't mesh. They don't speak the same language. And resolving that's the grand challenge.
And what's so interesting, almost ironic, is how this puzzle ties back to Einstein himself, specifically to the year 1935.
1935.
Right.
Because in that one year, Einstein published 2 papers on things he thought were, well, problems. Pathologies, I think he called them.
That's the term he used, yeah. He saw them as signs something was deeply wrong. First, with Podolsky and Rosen, was the EPR paradox.
The famous one.
Right. It was basically a critique of quantum mechanics, pointing out what he called spooky action at a distance.
Quantum entanglement, that instant connection between particles no matter how far apart. He hated that.
He really did. He thought it proved the theory was, incomplete, missing something.
Okay, so that was the first pathology. What was the second? Also in 35.
The second, this time just with Rosen, explored something within his own theory, general relativity. These things called Einstein-Rosen bridges.
Wormholes.
Wormholes, exactly. Theoretical tunnels through space-time. But back then, they were seen as just mathematical quirks, probably unstable, not physically real things.
Just artifacts of the equations.
Pretty much. So for, nearly 80 years, these two ideas, spooky quantum entanglement and geometric wormholes, lived in completely separate worlds.
Totally unrelated. One quantum weirdness, one a gravitational footnote.
Until 2013. And this is where it gets really wild. Juan Maldacena and Leonard Susskind proposed something audacious.
ER
EPR. Their claim wasn't just that these things are similar or analogous. No. They propose they are 2 different descriptions of the exact same thing, the same underlying physical reality.
Wait, so the spooky action is the wormhole connection, geometrically.
That's the core of the conjecture. The spookiness has a shape, a geometric form.
Okay, wow. And that, for you listening, is our mission today. We're going to dive deep into this. How could 2 things Einstein thought were flaws actually be the key? Maybe the key to a whole new picture where space-time itself isn't fundamental.
But emerges somehow from entanglement.
Exactly. So let's unpack this. This is your shortcut to understanding ER, EPR.
Yeah.
Let's get into it. Okay, so to really get ER, EPR, we need to properly understand the 2 sides, right? The ER and the EPR that Einstein himself flagged. Let's start with the wormholes, the Einstein-Rosen bridge side. That comes from general relativity.
Right. And GR, at its heart, is about mass and energy warping spacetime.
Now, that warping tells objects how to move. That's gravity.
Exactly. And probably the most dramatic prediction of GR is the black hole.
Right. Collapsed star, insane density, this point of no return, the event horizon.
Nothing gets out once it crosses that horizon, not even light.
But Einstein and Rosen, back in 35, they were looking at the math for a specific type of black hole, weren't they? An eternal one.
Yes, an idealized one that's always existed. And the equations kind of spat out something unexpected. Not just a black hole, but also its opposite, a sort of time-reversed version, a white hole.
Something things come out of.
Theoretically, yes. And the really weird part was that the singularity, the crunch point inside the black hole, seemed mathematically connected to the singularity inside this white hole.
And that connection is the ER bridge, the wormhole.
That's it. It's like a tunnel, a potential shortcut through space-time. Think of taking a sheet of paper, that's your space-time.
Okay.
Fold it over, then punch a hole through both layers. The tube connecting those holes is your shortcut, your ER bridge.
Ah, I see. The 3D tube through the folded 2D sheet.
Right. And this is absolutely crucial. Later work by Wheeler and Fuller in the 60s showed these ER bridges are incredibly unstable.
You can't actually go through them.
Nope. Try to send even a single photon through, and the throat of the wormhole pinches off almost instantly. It collapses.
So not a useful shortcut then.
Not unless you have something called exotic matter. Stuff with negative energy density.
If we don't know exists.
Right. So these classical ER bridges are non-traversable. And keep that non-traversability in mind because it becomes really important for ER EPR to make sense.
Okay, non-traversable wormholes. Got it. Now let's switch gears to the other side. The EPR paradox from quantum mechanics. Einstein's other 1935 headache.
Yeah, he helped create quantum theory, but he deeply distrusted its implications, especially entanglement.
That spooky action. So remind us, what is entanglement again?
It's when two or more particles become linked in such a way that their fates are tied together no matter the distance. The classic example is electron spin.
Spin up, spin down.
Right. Say you create two electrons with a total spin of 0. If you separate them, send one to London and one to Tokyo, and measure the one in London, say it's spin up.
Then the one in Tokyo instantly becomes spin down.
Instantly. Faster than light communication seems to happen, though you can't actually use it to send a message. But that instantaneous correlation is what bothered Einstein.
He called it spooky because it seemed to violate locality, the idea that influences should travel at or below light speed.
Exactly. He argued that if you can know something about the Tokyo electron by measuring the London one without disturbing Tokyo, that property must have been real all along.
So quantum mechanics must be incomplete. It's missing some hidden variables that predetermine the outcomes.
That was his argument. Restore locality, restore realism. And for a long time, it was, mostly a philosophical debate.
Until John Bell came along in the 60s.
Right. Bell figured out a way to actually test this experimentally. Could local hidden variables explain these correlations?
And the experiments, starting with John Clauser in the 70s.
They overwhelmingly showed Bell was right, and Einstein on this point was wrong. The inequalities derived from local hidden variables were violated. Quantum mechanics' non-local predictions held up.
The correlations are spooky. They are real. It's fundamental.
It seems to be a fundamental feature of reality, yes. Not a flaw in the theory.
Okay, so here's the irony you mentioned earlier. Einstein flags these two things, unstable wormholes in GR, spooky entanglement in QM as problems.
Deep problems, he thought.
But maybe they're not problems at all. Maybe they're clues pointing toward each other. You mentioned a deep connection related to causality.
Yes, think about it. The ER bridge is non-traversable. You can't send anything through it faster than light or even at all. It protects causality and general relativity.
Okay.
And in quantum mechanics, entanglement, despite being instantaneous, cannot be used to send information faster than light. That's the no communication theorem. It protects causality in QM.
So both theories have these features, wormholes and entanglement, and both features have built-in mechanisms to prevent faster-than-light signaling.
Exactly. Both GR and QM independently, robustly forbid causality violation in these specific contexts. That shared principle, that deep consistency, is a really powerful hint. It's not trivial.
It suggests the non-traversability of the wormhole might be the geometric picture of the no communication rule for entanglement.
That's the bridge, conceptually. It sets the stage perfectly for Maldacena and Susskind in 2013.
All right, this brings us right to the heart of it. ER EPR. So after nearly 80 years of these ideas being separate, how exactly did Maldacena and Susskind propose to link them? What's the core claim?
The core claim is breathtakingly simple and profoundly radical, they said. Take a pair of maximally entangled quantum systems like our EPR pair of electrons.
Okay.
That pair is connected by a non-traversable wormhole, an Einstein-Rosen bridge.
Not is like, or is analogous to, but is
An identity.
an identity. Two different ways of describing the same underlying physical reality. One description is quantum mechanical, talking about entanglement and non-locality. The other is geometric, talking about space-time tunnels.
And initially, they focused this idea on entangled black holes, right?
Mhm.
Which kind of makes intuitive sense, connecting GR's extreme objects. That was the starting point, yes. But the idea quickly expanded. They proposed it applies to any entangled particles. Electrons, photons, quarks, anything.
But those aren't black holes. So the wormholes connecting them wouldn't be huge space-time tunnels.
No, exactly. For elementary particles, we'd be talking about microscopic, likely Planck-scale wormholes. Tiny, tiny connections woven into the fabric of reality. But still, the principle is the same. The entanglement is the wormhole.
The spooky action gets a physical shape.
It gets geometry.
Okay, let's pause there because the implication is just huge. If this is right, it means space-time, the stage on which everything happens, the smooth geometry we see.
Yeah.
It's not fundamental.
That's the most revolutionary takeaway. It suggests space-time is emergent. It's built up from something more fundamental.
And that something is quantum entanglement.
Yes. The smooth fabric of space-time we experience is, in this picture, like a macroscopic illusion arising from this incredibly complex, vast network of quantum connections. Susskind and Maldacena have this great phrase.
Which one?
Entanglement is the thread that sews space together.
Wow, so space itself is stitched together by these quantum links. That really flips the usual picture on its head.
Completely. Normally, we think of quantum fields living in space-time. This suggests space-time is built from the quantum information, from the entanglement.
That's a serious paradigm shift. But okay, Such a wild idea needs some solid theoretical grounding, right? It can't just be a neat philosophical point. Where does the evidence, or at least the theoretical support, come from?
Absolutely. And the main support comes from a powerful framework in theoretical physics called the holographic principle.
Holography, like on a credit card.
Sort of analogous. The idea, which was inspired by studies of black hole thermodynamics specifically, the Bekenstein-Hawking entropy formula.
Which relates entropy to the area of the event horizon.
Exactly. It suggested, counterintuitively, that the information content of a volume of space might actually be fully described by degrees of freedom living on its boundary, a lower dimensional surface, like a 3D image encoded on a 2D hologram.
Okay, so information in the volume is encoded on the surface. How does that connect to ER EPR?
The crucial step was Juan Maldaceno's discovery in 1997, the ADS-CFT correspondence.
Anti-de Sitter conformal field theory. This is a big deal in string theory and quantum gravity, right?
Huge. It provided a concrete mathematical example of the holographic principle. It proposes an exact equivalence, a duality, between two seemingly very different theories. On one side, you have a theory of quantum gravity, often arising from string theory, living in a specific kind of negatively curved spacetime called anti-de Sitter space, or ADAS. We call this the bulk.
Okay, gravity in the bulk ADAS space.
On the other side, you have a quantum field theory without gravity, a conformal field theory, or CFT, living on the boundary of that ADS space.
No gravity on the boundary, CFT, so it's a dictionary. Translating between gravity in the bulk and quantum fields on the boundary.
Precisely. It's a mathematical dictionary. And it's incredibly useful because it's often a strong-weak duality. Hard problems in the gravity theory, when gravity is strong, can become easy problems in the boundary quantum field theory, where couplings are weak and vice versa.
A powerful tool.
Yeah.
But where does entanglement geometry come in? Is there a specific entry in this ED-SCFT dictionary for that?
There is, and this is arguably the quantitative and conceptual linchpin for ER EPR. It's the Ryu-Takayanagi formula proposed in 2006.
RT formula. Okay, what does it say?
It provides an incredibly elegant recipe. It says that the entanglement entropy of a region in the boundary CFT,
A measure of quantum entanglement.
yes, is precisely equal to the area of a certain minimal surface in the bulk ADS spacetime that hangs down from the boundary of that region.
Oh, so a quantum information quantity, entanglement entropy, is directly translated into a purely geometric quantity area in the bulk gravity theory.
Exactly. It's the Rosetta Stone connecting entanglement and geometry within this holographic framework. And work building on this, notably by Mark van Ramsdonk, showed something even more suggestive.
What was that?
Van Ramsdonk showed that if you take two separate CFTs living on two disconnected boundaries and you start entangling them quantum mechanically,
Okay.
what happens in the bulk gravity description is that a smooth connected geometry, essentially a wormhole, emerges, bridging the two previously separate spacetimes.
So turning on entanglement literally stitches the bulk spacetime together.
That's what the ADS-CFT dictionary tells us. Disentangling them rips the spacetime apart. It's a concrete mathematical realization of entanglement sewing space together.
This provides the proof of concept then. Within this specific theoretical model, geometry does emerge from entanglement.
Precisely. It shows that the ER EPR idea isn't just hand-waving. It has a concrete realization in a controlled theoretical setting. It reinforces this radical notion. Entanglement is primary, geometry is secondary, emergent, holographic.
Okay, so we have this theoretical framework at a CFT where EPR seems to work beautifully. What are the payoffs? Does this help us solve any long-standing puzzles in physics? The big one that always comes up is the black hole information paradox.
Yes, resolving the information paradox is one of the major claimed successes or potential successes of ER EPR.
Remind us of the paradox again. Stephen Hawking showed black holes aren't entirely black, they radiate.
Right, Hawking radiation back in the 70s, he calculated that black holes slowly evaporate. But the radiation seemed thermal, random, containing no information about what fell in.
Which clashes violently with quantum mechanics, because QM says information is never truly destroyed. It has to be preserved, what they call unitarity.
Exactly. So does gravity via black holes violate quantum mechanics? Or is Hawking's calculation somehow incomplete? That's the paradox.
And it got even trickier recently, didn't it, with the firewall paradox?
Yes, the AMPS paper in 2012, Almheri, Marolf, Polchinski, and Sully. They sharpen the paradox using a fundamental principle of quantum information called entanglement monogamy.
Monogamy. You can't be married to two people.
Huh. Basically, a quantum system can't be maximally entangled with two separate systems at the same time. It can share entanglement, but not be fully tied to both.
Okay, how does that create a firewall? Walk us through the AMPS argument.
Okay, think about a particle pair created near the black hole horizon. One particle falls in, let's call it A. The other escapes as Hawking radiation, call it B.
The infalling partner and the outgoing radiation.
Now, for the event horizon to be smooth and unremarkable, as general relativity suggests, the no-drama principle, particle B must be maximally entangled with its infalling partner A.
Okay, entanglement pair AB for a smooth horizon.
But for information to escape the black hole and preserve unitarity, that same outgoing particle B must also be maximally entangled with all the Hawking radiation emitted much earlier. Let's call that C.
So B needs to be entangled with A inside and with C, faraway radiation.
Yes. And that's the forbidden quantum polygamy. AMPS argued something has to give. Their conclusion was that the entanglement between the infalling A and outgoing B must be violently broken right at the horizon.
Creating a high-energy curtain, a firewall that would incinerate anything trying to cross.
Exactly. It saves quantum monogamy and information preservation, but it destroys Einstein's smooth spacetime at the horizon. A very unpleasant choice.
So how does ER EPR propose to get us out of this mess? It sounds like a real catch-22.
ER EPR offers a really elegant escape route. It says the premise of the AMPS argument is flawed. You shouldn't think of the infalling particle A and the distant radiation C as two separate independent systems.
Why not?
Because according to ER EPR, they're connected by a wormhole. The entanglement between the black hole interior, where A is, and the early radiation C is an ER bridge.
So A and C are two ends of the same wormhole system.
Precisely. They form a single, unified quantum system. So when the outgoing particle B gets entangled, it's entangled with this combined AC system through the wormhole.
So B isn't trying to be maximally entangled with two separate things. It's entangled with one unified thing, the AC wormhole system. Monogamy is preserved.
Monogamy is preserved, the firewall isn't needed, the horizon can remain smooth, and information isn't lost. It's encoded non-locally in these entanglement wormholes connecting the interior to the radiation.
That is actually quite beautiful. The wormhole connection itself resolves the apparent contradiction.
It suggests that space-time geometry isn't just a passive background. It dynamically reconfigures itself, creating these ER bridges precisely to uphold the laws of quantum information. The wormhole becomes the guardian of quantum principles.
Which brings us back again to that non-traversability point. It's essential, right?
Yeah.
Because if these wormholes were traversable, you could potentially violate causality or send information faster than light using the entanglement.
Absolutely crucial. The non-traversability of the ER EPR wormhole is the geometric counterpart to the no communication theorem in quantum mechanics. They perfectly mirror each other, ensuring causality is always respected, no FTL shenanigans allowed.
And we should be clear, these ER EPR wormholes, this fundamental manifestation of entanglement, are different from the hypothetical traversable wormholes people talk about in sci-fi, right? Those require exotic matter.
Completely different beasts. Traversable wormholes, if they exist, seem linked to concepts like quantum teleportation, but require that physically dubious exotic matter. ER EPR wormholes are proposed to be everywhere, linking any entangled particles, and are inherently non-traversable.
And this idea fundamentally shifts how we think about where information is. It's not just located at a point, it's in the connection itself.
Yes, it's a more relational, almost topological view. The information is encoded in the structure of the wormhole, the pattern of entanglement.
Okay, the potential payoff is huge, resolving the information paradox, unifying geometry, and quantum information.
Yeah.
That sounds amazing. But, extraordinary claims require extraordinary evidence. What are the major hurdles, the sticking points? Where do critics push back on ERPR?
And there are significant ones, both conceptual and quantitative. It's definitely not a settled issue.
Let's start with the conceptual problems.
Yeah.
You mentioned linearity earlier.
Right. Quantum mechanics is fundamentally linear. You can have superpositions. An entangled state can be written as a sum of unentangled states.
Well,
But geometry, general relativity, is highly nonlinear. So if the entangled state is the wormhole, how does this definite geometric structure suddenly emerge or switch on from a superposition of states which individually correspond to no wormhole?
how does the smooth, nonlinear geometry arise from the linear rules of quantum superposition? That connection is fuzzy.
It's a major conceptual gap. How do you bridge that fundamental difference in mathematical structure? Another issue is measurability.
How so?
Well, Entanglement itself, especially for a single pair of particles, isn't directly measurable in a single shot.
Yeah?
It's fundamentally a statistical property you infer from correlations over many measurements.
Right, you need to measure many pairs to confirm entanglement.
But geometry, like the existence of a wormhole, even if its interior is hidden, seems like a definite classically real property. How can a statistical unmeasurable quantum property be identical to a definite geometric one?
That feels like comparing apples and oranges.
Proponents might argue the wormhole interior is also hidden from view, making the comparison less direct, but it's still a point of contention. How does the reality of geometry map onto the reality of quantum states?
Okay. Those are deep conceptual issues. But you also mentioned quantitative problems, like when you actually try to put numbers on this.
Yes, and this is where things get really problematic, sometimes called the mass energy catastrophe.
That sounds dramatic.
It kind of is. The problem arises when you try to take the quantitative relationship from AD-SCFT, the Ryu-Takayanagi formula relating entanglement entropy to area, and apply it naively to, say, a simple entangled electron-positron pair in our actual universe.
Okay, so applying the holographic dictionary outside of its native AD-SCFT context.
Exactly. If you calculate the expected geometric size of the wormhole connecting an electron and positron based on their entanglement, and then use standard general relativity to calculate the energy or mass associated with such a warped space-time geometry, the numbers are wildly off.
How wildly?
The calculated energy of the wormhole comes out to something like 10 to the power of 27 electron volts, keV.
Lun 27 eV. What's the actual mass energy of an electron or positron?
About 500,000 eV, so around 106 eV.
So the calculation says the wormhole energy is 21 orders of magnitude large.
Yeah.
That's absurd. Creating entanglement would cost near infinite energy.
It's astronomically huge, yes. And it gets worse if you imagine, say, an entangled photon dragging the supposed wormhole along with it.
Yeah.
The calculation implies the photon would acquire an effective mass due to this wormhole connection, and that effective mass violates experimental limits on the photon's actual mass by about 32 orders of magnitude.
32. Well, that's not just wrong. That's spectacularly wrong.
It's profoundly inconsistent with observation. One more example. If you had a macroscopic collection of, say, 109 entangled pairs, which isn't that many in condensed matter systems.
Like in the solid.
Yeah. This naive calculation suggests that samples should have an extra gravitational mass purely from the entanglement wormholes of about 7 kilograms.
7 kilos. Just from entanglement. Has that ever been seen?
Never. No experiment has ever detected such an anomalous weight associated with entanglement.
So the quantitative predictions, when applied to real-world particles, seem to fail catastrophically. What does this mean for ER EPR?
Well, it highlights what some call the two-language problem. The dictionary provided by AD-SCFT works beautifully in that specific theoretical context, linking entanglement and geometry. But if you try to use that same dictionary directly for particles in our universe, the translation gives physically nonsensical results.
Does it mean ER EPR is just wrong for our universe, or maybe only applies in the special ADS case?
It could mean several things. Maybe ER EPR is a context-dependent duality, only truly holding in environments like AD-SCFT. Or maybe the wormholes connecting elementary particles are fundamentally quantum objects themselves, not described by classical GR formulas, so those calculations are just invalid.
Okay, what's the defense then? If the calculations are wrong, how do proponents respond?
The standard defense is exactly that. You can't use classical general relativity formulas to describe these deeply quantum wormholes. The calculation itself is flawed.
Doesn't that make the conjecture difficult to test? If any calculation that gives a wrong answer can be dismissed as using the wrong classical tools.
That's the criticism. It risks pushing the conjecture into an unfalsifiable state for elementary particles. It remains a powerful, compelling heuristic, a new way to think about space-time and information, but its status as a predictive framework, especially outside AD-SCFT, is shaky due to these quantitative issues.
So wrapping this up, where does that leave us with ER EPR? It's this incredibly elegant, provocative idea linking Einstein's pathologies.
Solving major paradoxes, potentially.
But facing really significant conceptual hurdles and these, well, catastrophic quantitative failures when applied directly to our world.
It's a mixed bag, definitely. Despite the challenges, it remains a hugely influential and active area of research. I think its real value, regardless of whether the identity holds literally for every entangled pair, has been the conceptual shift it's driven.
How so?
It's forced physicists to take seriously the idea that quantum information, particularly entanglement, might be the fundamental building block, and space-time geometry might be emergent. It's put information theory right at the heart of quantum gravity research.
And research is ongoing. People are refining the idea.
Oh, absolutely. There's work trying to reformulate ER EPR more carefully, perhaps as an operational theorem about quantum information processing. And within ADAS-CFT, people are constantly finding new computable realizations demonstrating its power within that native framework.
That's also important to remember. As you said, it's not the only idea out there trying to bridge these gaps, right? Are there prominent alternatives?
Yes, definitely. Loop quantum gravity, for instance, takes a completely different approach.
How does that work?
LQG tries to directly quantize space-time itself, breaking it down into discrete atoms or quanta of space and volume. It offers its own way to resolve the information paradox, maybe via a quantum bounce, where the black hole singularity is avoided and it transitions into a white hole, releasing information.
So different paths towards quantum gravity.
Different paths, different pictures of reality. ER EPR is one compelling narrative, but not the only one.
So to be clear for everyone listening, ER EPR is, as of now, highly speculative. It's not proven fact.
Not by a long shot. It's a powerful conjecture, a guiding principle for a lot of research, but still firmly in the theoretical realm.
But its impact seems undeniable, shifting the focus onto information and entanglement as potentially the true bedrock of reality.
I think that's right. The debate around it is almost like trying to learn a new language for the universe, where quantum information provides the grammar, the rules, and space-time geometry is the emergent story written with that grammar.
That's a great analogy.
Yeah.
So a final thought for our listeners to ponder.
Well, just consider what it would truly mean if this picture, or something like it, is right. If the solid, reliable structure of space-time that seems so fundamental to us is actually an illusion.
A hologram.
A hologram or a macroscopic view of this incredibly complex, frantic, ghostly dance, as Einstein might have put it, of quantum entanglement happening underneath. What does that really imply about the nature of space, time, and our place within the cosmos?
A lot to think about. Thank you for guiding us through that deep dive.
My pleasure. It's fascinating stuff.